everyone. Today we're going to be taking notes on page 22 in our notebook. We're going to still be talking about solution types. We're still going to be solving equations, but today we're really going to focus on combining like terms, especially with variables on both sides of the equal sign. So please pause the video and write down page 22, solution types, combining like terms, and you can also write down question number 1, which is right here on the left-hand side. I'm going to pause my video so I can get it written down, and then I'll start solving it. So last week we focused on the solution types, but mostly we just focused on variable on both sides. A few weeks before that we focused on combining like terms with our complementary and supplementary angles. So now we're going to throw it all together. We're going to be combining like terms, and we're going to be solving with equations with variables on both sides. So here's my equal sign. And I no longer have just 2 terms on the left and 2 terms on the right. I have more than 2 terms, so that means we're going to have to combine some terms. That's where we use the caret, and we follow whatever sign we have. So on the left-hand side, we have 7n minus 2n, which makes 5n, and I bring down the minus 7, equals, on the right-hand side, I have a 5 plus a 3. So I'm going to bring down the 2n, and then 5 plus 3 is 8. Now, if you remember what we talked about last week, if the variable coefficients are the same, that's either going to be infinite solutions or no solution, but because our variable coefficients are different, it's going to be one solution, and so we just keep solving. So now we have a variable on each side. This is not when we use the caret. When the variables are on the same side, we use the caret, and we combine them. When variables are on opposite sides, you do the opposite to get rid of them. So I'm going to get rid of the positive 2n by minusing 2n from the right and minusing 2n from the left. When I do that, I get 3n minus 7 equals 8. And again, now it's just our simple 2-step equation where I want to get 3n by itself. So I get rid of the thing next to my finger, which is minus 7. So I'm going to add 7 to the left, add 7 to the right. I get 3n equals 15. And then that last step is to divide both sides by 3 because it's with the variable. So I divide by 3, oops. And I get n equals 5. So this is an example of one solution. And the one thing that would keep them balanced is n equals 5. All right, number 2. Oh, look at that. Number 2. So go ahead and pause the video and write it down and resume the video when you're ready. All right, so number 2, we still have variables on both sides, and we also have some combining of like terms. So I'm going to draw my line at the equal sign, and I'm going to look at the left. On the left-hand side, I have a 3 and a 9 on the same side, so I'm going to use a caret to combine them, and I get 7x plus 12 equals, on the right-hand side, I have 3 terms, and I have a 9x minus a 2x, which is a 7x plus 2. If I look here at my equation that I have on both sides, I notice that I have a 7x on both sides, and my values are not the same. So this is either going to be infinite solution or no solution because my coefficients are the same on my variable terms. So it doesn't matter which one we get rid of, which we've been told this whole time, but I'm going to minus 7x from the left and minus 7x from the right. When I do that, I get 7x minus 7x, which makes 0, and I get 12 equals a 7x minus a 7x makes 0, and I'm left with a 2. Now, some of you will say, well, subtract 2 from both sides, or subtract 12 from both sides, so we can solve for x. But we don't have an x anymore. All we have is a statement that says, does 12 equal 2? So 12 does not equal 2. So this is an example of no solution. No number would keep the 2 sides balanced. So this is an example of no solution because 12 does not equal 2. There are no variable terms left. All right, let me get number 3 up, and then you can write it down. So go ahead and pause the video, write it down, and then we'll work on it together. All right, number 3, we have variables on both sides, and we have some terms that we're going to combine. So I'm going to draw my line at the equal sign, and I'm going to look at the left-hand side and see what there is to combine. I have a 12k minus an 8k. which makes 4k. They're on the same side, so I follow the sign, and I bring down the minus 18, equals 4k. And then this is my favorite kind of mistake that students will make here, is that they'll say 20 plus 2 and then carry the minus sign, but that's not 20. It's a negative 20 plus 2. So please use a calculator, type it in, negative 20 plus 2, because the negative belongs to the 20. Negative signs aren't just tag-alongs. Negative 20 plus 2 is a negative 18. If you had combined negative 20 incorrectly, which I will show you here in just a second, you'll come up with a different solution. Now here I can see that everything is exactly the same on both sides, so this will always be balanced no matter what I do. It's always a good habit to get rid of your variables on both sides, so I'm going to minus 4k from both sides, and what that happens is 4k minus 4k makes a 0, and I get negative 18 equals a 4k minus 4k equals 0, and I get a negative 18 on the right. Again, some of you might say, divide both sides by negative 18 to get k by itself. There is no letter k left. The answer is not 1. The answer is not negative 1. The answer is not negative 18. The answer is, does negative 18 equal negative 18? And the answer is yes, they do equal each other. That's a true statement. And because it's true, this is an example of infinite solutions. All the values of x or k in this example would keep it balanced. Okay, so this is infinite solutions. Now I do want to talk about a special case in where if we had combined them incorrectly, what would happen? So this is in a hypothetical world. We're all going to use our calculators, and so we're not going to make this mistake. But in a hypothetical world, if I had written this as 12k minus 18 minus 8k equals 4k minus 20 plus 2, and drawn my line at the equal sign, and combined my like terms on the left, 4k minus 18, and combined my terms on the right and got 4k. And if I had combined these incorrectly because I didn't use a calculator and I considered that negative to be a tag along, and I had said 20 plus 2, which is 22, and bring down the negative, that messes up our equation. That's why it's so important to combine your like terms correctly by using a calculator, especially if you don't know your positive and negative rules. Because now when I subtract 4k from both sides, we would be left with negative 18 equals negative 22. Okay? And in that scenario, those two things are not equal to each other. So a simple mistake, okay, a simple mistake can lead us to getting the wrong type of solution. So please make sure that if you don't know your positive and negative rules, that you use a calculator. Okay, so a simple mistake of negative can make our equation go from infinite solution to an example of no solution. Thanks for watching the notes on page 22. If you need to pause, rewind, and watch it again, please do so, and work on whatever is assigned for the day. Have a good day. Thank you. Bye.